Spike2 includes channel processing options that can be applied to waveform or real wave data. Channel processes are dynamic and do not affect the data stored on disk, but use the raw data to display a calculated version of the process trace on screen. In these examples, I have duplicated the channels and displayed the processed versions in red for comparison with the raw data in green. Some common uses for channel processes include the conditioning of data to more reliably detect and analyze features of interest, such as area under the curve for EMG, or EPSP peak times. Other channel processes can aid artifact removal, as in this processed intracellular recording. In this tutorial, we will take a closer look at some of these process options. To only show the raw data, I can double-click the channel to hide all others. In our first example, we will look at some of the processing options for EMG data. Channel processes are applied from the Channel Process dialog, which is available from the Analysis menu, or by right-clicking on the channel. The channel you want to process and the processes to apply are selected from the drop-down lists in the dialog. Use Add to add a new process to the end of the list. Rectify sets all negative values to positive values of the same level. It is possible to apply multiple channel processes to a data channel. For example, rectification followed by a smooth process, which applies a moving average filter to the data. This preserves the area under the curve. The list shows the processes that will be applied in order. Many of the processes, like smooth, use arguments such as a time value. Points within the time range either side of each data point are used to calculate the process trace. Argument settings for the selected process can be changed here. Apply applies the current processes and updated argument settings to the selected data. Delete removes the selected process. The Clear button removes all processes from the channel, reverting back to the raw data. If a channel has been modified in any way, the channel number is displayed in red. To view a copy of the raw trace alongside the processed data, use Duplicate Channel from the Analysis menu. Channel processes are unique to individual channels and are not copied with any duplicates. You can copy all the processes set for the current channel to other channels in the file. Select the target channels by clicking their channel numbers, usually on the left edge of the time view, and click the Copy button. For our second example, let's take a look at removing artifacts. If your data has occasional points with large errors, like the spike artifacts in this intracellular recording, the median filter process may be useful. The median filter process takes a time period in seconds, p, as an argument. The output at time t is the median value of the input data points from time t minus p to t plus p seconds. The median is the middle point after the data has been sorted into numerical order. If we compare this to the raw trace, we can see that the process has preserved most of the data while removing the spike artifacts. Median filters are non-linear. You should set the smallest time constant possible to get a useful result. Our third example will look at how channel processing can improve detectability of peaks. In this example, the EPSPs are difficult to detect because of the oscillation of the baseline membrane voltage. Let's access the Channel Process dialog by right-clicking on the channel and select Slope from the drop-down process list and click the Add button. The slope process changes the channel scale. Double-click on the y-axis and click Optimize to show the process data. Slope uses one argument, a time period in seconds. The processed version of the channel now shows detectable peaks marking the position of the maximum slope for each EPSP in the raw trace. Many other channel processes are available. DC Remove removes baseline drift. Time Shift moves data forwards or backwards on the x-axis. Downsample, Interpolate and Match Channel can all change the sample rate of a channel. RMS Amplitude displays the RMS amplitude of a signal, and Fill Gaps will fill in gaps in a waveform. And that's it for our first introduction to channel processes. I hope that you've found this tutorial useful.